everyone, let's do this problem. It says the oxygen-hydrogen bond in water is formed by the overlap of an s orbital with an sp3 orbital. Why is this bond stronger than the bond that would be formed by the overlap of an s orbital with a p orbital? So let's draw the overlap of an s orbital with a p orbital, and then we'll compare that to the oxygen-hydrogen bond mentioned in the problem. So drawing an s orbital, we know that has a spherical shape, and a p orbital has this sideways double lobe shape with two different phases. All right, and then drawing an s orbital with an sp3 orbital, which, where does that come from? Let's draw water really quick. So we have oxygen with two hydrogens. That oxygen has two lone pairs. So we see that we know hydrogen has an s orbital only, and this oxygen has 1, 2, 3, 4 charge centers, which is why it is sp3 hybridized. So drawing again the s orbital, our sphere, but now the sp3 hybridized orbital is going to have two lobes like the p orbital, but since we have the hybridization of 4 orbitals, the s and 3 p orbitals, that lobe, one lobe is going to be much larger due to higher electron density. So the sp3 is going to have a larger lobe than the p orbital, which has a smaller lobe. And that means it's going to have a higher electron density, the sp3 orbital, compared to that unhybridized p orbital. So when the s orbital is overlapped with an sp3 orbital, the magnitude of that overlap is much stronger than the overlap between the s and the unhybridized p orbital. Therefore, the bond formed by the overlap of an s and sp3 orbital is going to be stronger than that bond that is formed by the overlap of an s and p orbital. So the correct answer for this problem is the large lobe of the sp3 orbital has a greater electron density compared to the p orbital. Therefore, the sp3 orbital overlaps more strongly with an s orbital. And that makes A the correct answer for this problem. That's it for this one. I hope this video was helpful, and thanks for watching.